Hi all, see this, here we need to find out the limit at x tends to 0 zx where the different problem functions are given. So here we are having the left hand side, right hand side and all that stuff, right? So first let us calculate what is our gx, right? It's very simple. So let's go ahead. So we can calculate that gx is equal to x by 2 is the denominator and we are having the integration 6fx 4t cube dt. That's it. Okay. Now see that if I apply the limit x tends to 2 gx, then it's became obviously limit x tends to 2 the same function. So just repeat it again. So 6 to fx 4t cube dt divided by x minus 2. Okay, that's it. Now see that you cannot apply that x into 2 limit here directly because here we'll definitely get some values, right? We don't know that, but it's obviously divided by x minus 2, right? So obviously it's maybe not defined, right? And we don't think that if as fx is known, if I perform the differential integration, right, and then we just take x by 2, x by 2 cannot be cancelled because here fx will be the function. Okay, so that's why we'll say that this limit doesn't properly defined or at the point x equal to 2, it becomes a singular point at this particular case, right? Now how we'll go ahead. So obviously we know that to solve this kind of problem we can able to apply the L'Hopital rule, right? So let's apply that. So therefore we have to differentiate the denominator and the numerator. Okay, let's go ahead. So therefore we can say that it's definitely equal to limit x tends to 2 d dx of whatever they are inside that integration, just write down at that moment now. So fx 4t cube dt divided by d dx of x minus 2. That's it. So now if I able to calculate our this differentiation, okay, it's done. So it's called, see that we are differentiating inside the integral sign. So it's called differentiation under integral sign. So here we have to use one important relation. Okay, let's see that. So that's called that in d dx of integration of phi 1x to phi 2x ft dt. If we are differentiating like this, we'll get it as f of phi 2x multiplied by phi 2 dash x minus we have f of phi 1x multiplied by phi 1 dash x. So that's called differentiation of under integral sign. Okay, so here we can easily apply that. So see here, by phi 1 is actually 6. So therefore this part will be removed because phi dash x is equal to 0. So we don't have that. We obviously able to write down in this case, right? So here what is my fx? Fx is equal to 4t cube, right? So therefore you'll see that for this particular problem, okay, that my fx or ft actually, sorry, is actually 4t cube. Okay, so that's why we just able to write down the given function. So let's write down that. Okay, so therefore here we will get that limit x tends to 2 gx is equal to d dx of that gives me that f of, so therefore 4t cube of phi 2x. What is phi 2x? That is here fx, right? So therefore we'll say that it is 4 of fx whole cube into f dash x. Okay, that's it. And obviously we'll have the limit now. That's it. Okay, but to remove the confusion, because see that here I use ftx, here also fx is present, right? So that's why I just remove that line. Okay, so you just check that here fx phi x is equal to phi 2x is equal to fx. So I just write f dash x, and here my function is 4t cube, and that 4t cube need to be calculated at the point phi 2x. So that's why I write fx whole cube, right? So that's it. So this is actually my limit. Okay, now see that what's the limit? So therefore you can apply that limit at that point. So that gives me that 4 of f2 cube into f dash of 2. Now see that here f2 and f dash 2 is already given. So therefore we just write it as 4 into 6 cube multiplied by 1 by 48. That gives me that 4 into 216, 6 cube divided by 48. That means that 48 is 12 and 216, that gives me 18. So that's why for this particular problem, obviously you see that option A, 18, is the correct choice. So any problem, whenever you have to apply the differentiation under the integral sign, that means that we are having an integration in the definite integration form and we need to apply the ddx, right? In that case, we will apply this formula, right? Then our job becomes simple. You can try it that it is 4t cube. So obviously this 4t cube becomes t to the power 4, right? So t to the power 4 divided by 4. So then you just apply that, you will get the same way. Okay. So think about that. Okay. Now, so it's t to the power 4 if I integrate it. So if I become integrate t to the power 4, if I substitute fx, right, we'll get it as f to the power 4. Now, if I differentiate again, right, because we are applying that L'Hopital rule. So it's become 4fx cube into f dash x. So see that, that's only we'll write here. Now, what's the use of that, right? Because in all problem, right, you may not be able to integrate it easily, right? So that's why we just use that. But for this particular problem, you can apply the direct integration first and then go ahead, right? But to learning process, we'll use that. Okay, that's it. Hope you understood the technique and the problem. Thank you.